Hello friends, I'm Dr. Sudha Rani, professor in the Department of Computer Science and Engineering. As part of the Java Lab series, today's experiment is write a Java program to show isAlive and join methods. So let us dive into what are these methods. Coming to isAlive is a method of the thread class in Java. And the purpose of isAlive method is to check whether a thread is currently running or not. So this gives a boolean value. So it returns true if the thread is alive, started and not yet finished. So it gives true. And it gives false if the thread has completed execution. The use case of isAlive. So where exactly we'll be using this isAlive to monitor thread status in multi-threaded programmings. Example, if you want to check if background tasks like file downloading and processing are still running or not, you'll be using isAlive. Coming to the join method, so join is also a method of the thread class. The purpose of the join method is to make the current thread wait until the thread on which join is called completes. So the use case of join method is synchronization. Ensure main thread or another thread waits for a worker thread to finish. For example, waiting for a data loading thread to finish before processing the data, or waiting for multiple threads to complete before calculating final results. So these are the use cases of isAlive and join methods. So let me walk you through the program. So first we have created two threads. The first thread and the second thread. Each thread prints its message a certain number of times. Say, like the count is given by the user. So those many times the message is printed with 100 milliseconds delay. Okay. Now in the main thread, what we are doing is we are checking whether the thread status is alive or not by using isAlive method, and waits for threads to finish using join method, and verify completion using isAlive again. Okay, so this is what we are doing. So in the main method, what we're doing is we are creating the object of the scanner class, and then read the user input for how many times each thread should print its message. Then we are creating instances of the threads, passing the message count to the constructors. Then starts the execution of both the threads in parallel. So we are calling first thread dot start and second thread dot start. JVM calls the run method of each thread implicitly. As soon as like we say start method, we call the start method. JVM implicitly calls the run method. So the run method of both the threads will execute in parallel. And once they execute, then we are checking the status of the threads, whether they are alive or not, right after starting. And this usually prints true because threads have been started. So we already have started the threads and then checking whether the threads are alive or not. So obviously like we'll be getting true because threads have started. And then the main thread waits here until first thread completes all iterations because we have joined the first thread to the current thread, which is the main thread. After join, main thread resumes and prints that first thread has finished, and main thread now waits until second thread finishes. Okay, so after first thread we have joined the second thread, so the main thread should not complete before second thread finishes. Okay, so once the second thread finishes, then only main can complete. So we are checking thread status after waiting. Both should print false since threads have completed, and then main thread ends execution after all threads have completed. So this is the use of isAlive and join. So let us look into various use cases of isAlive and join. Say for example, multiple download threads running in parallel. So use isAlive to show progress bars of active downloads, and use join to wait until all downloads finish before merging the files. Okay, so that is one of the use case. Another use case of isAlive and join could be in data processing. So multiple threads process parts of large data. So main thread waits using join before combining the results of all these threads. And the next use case is game programming. So background threads for animations or AI logic. So main thread uses isAlive to check if certain animations are still running before allowing next action. So these are all the various use cases of isAlive and join. So when we run the program, the user is asked to enter the number of messages for each thread. For example, if we enter 5 for both threads, the threads start running concurrently. First, both threads begin executing their run methods almost at the same time. This means the messages from first thread and second thread are interleaved. For instance, you might see message from second thread 1 and message from first thread 1. The exact order can vary because thread scheduling is handled by the JVM and operating system, so you might get a different ordering. Right after starting the threads, the main thread checks whether the threads are alive using isAlive. At this point, both threads are still running, so isAlive returns true for both. Next, the main thread calls first thread.join. This causes the main thread to pause and wait until first thread has completed all its messages. Only after first thread finishes does the main thread prints. The first thread has finished and proceeds to wait for the second thread using the second thread.join. After second thread completes, the main thread prints second thread has finished. Finally, the program checks isAlive again for both the threads. Since both threads have completed, isAlive now returns false. The final line, main thread has finished, indicates that the main thread has completed its execution only after waiting for both threads to complete. So I hope this video is helpful to you. Thank you for watching.